So let's compare our implementation with sklearn. How we can do so? We need to create an object of the kNearestNeighbor classifier class in sklearn, just like this, and we imported this class before, right, in the first cell. Now, as you can see, this class takes many inputs, but the most important input is the number of neighbors. And as you can see, the default value for the number of neighbors is 5, and we have other hyperparameters that we can use. For example, we have the weights, we have the metric, we have b, and so on, right? But the most important one is k, which is the number of neighbors. So we will just have k equal 3 here, and this will return an object of the kNearestNeighbor classifier from sklearn. Now, in order to train our knn, we need to use the fit function inside this class, right? So we will just write knn.fit, and we will give it the normalized x train and the y train. Okay, now after that, in order to classify the test points, right, the x test, we will write knn, this is the object we created, and we will call the predict function inside this object, okay, and we will use the normalized x test, and this should return the labels, right, the labels for the testing dataset. So if we run this, you will see that we have 2, 1, 0, 2, and so on. So instead of just looking at this one and looking at this one and trying to see if they are equal or not, we can use a function inside NumPy called array equal. So we give it 2 arrays or more than 2 arrays, and it will return either true or false, and it will return true if the arrays are equal, and it will return false if one of them is different from the others. Okay, so as we can see here, we have 2, 2, 1, 1, 0, 0, and so on. So if we print NumPy array equal and we give it the y prediction we got using sklearn and the y prediction we got using our own implementation, it will return true. So this means that our implementation is exactly like the knn classifier from sklearn. So we implemented the knn algorithm from scratch, 100% correct. And in order to assure this, we will print the accuracy of our implementation and the accuracy of the sklearn implementation. We will use the accuracy score function we imported in the first cell. It's also coming from sklearn. So we will give it the true labels and the predicted labels. Of course, the true labels are the y-test, right? So as you can see here, the accuracy of our implementation is, and we have this is the accuracy. And then we have the accuracy of sklearn implementation is, and this is the accuracy. So if we run this, you will see that our implementation accuracy is 96%, and the sklearn implementation accuracy is also 96%. So they are equal. Okay, so this is how we can use the sklearn implementation and how we can compare it with our own implementation. Of course, in all the other courses, you will see that instructors just importing this class and then using the functions inside this class, and you don't really know how the algorithm works. But right now, you know exactly how the algorithm works from scratch because we built it together, right? So in the next video, we will perform hyperparameter tuning using k-fold cross-validation, and this is super important. So let's go to the next lesson.